Welcome back. Good morning. Now we're going to move on to 5.2, Descriptive Statistics. And with descriptive statistics, here we're going to get into some of our calculations. We're going to look at some of the things that we hopefully were familiar with, and looking at some new things along the way too. Remember, we'll be able to use these descriptive statistics in our IAs later. So when it comes to descriptive statistics, really, there's two different types. There's two main types. The first is measures of central tendency. And these measure how close our data, how close the information is gathered around itself, how close it is. And there's four of these. Four of these that we need to know, and I think we know these already. They are the mean, which we know is the arithmetic average. Now, the mean has a special symbol, X bar. That's the symbol we use for mean. It even has a crazy formula. Now, we know what the mean is. We know how to find it. You just add up all the numbers and divide by how many numbers there are. But the formula for mean looks like this. X bar is equal to the sum from I equals 1 to n of f of I of x sub I divided by n. Now all this crazy formula means the sum, I'm adding up all the data. I'm adding up each of the individual pieces from 1 to n. That's how many there are, n. That's why it's divided by n. So here is the sum, and then dividing by n. There's the dividing by n. So that's my arithmetic mean. So if you see this crazy formula later, that's all that's going on here. Don't stress about that. The next one is the mode. And we know the mode. The mode is the most frequently occurring number in our data set. The median. The median is the middle number. If I put them all in order, now this is important. For a median, they have to be in order. Don't just take your raw data set and pick the middle number. And it doesn't matter from the least to the greatest or the greatest to the least. It doesn't matter. That would be the middle. Now, if it's an even data set, you're going to have two numbers in the middle, and you're going to take what's halfway between them. Just add them together and divide by 2. And then finally, the mid-range. The mid-range is just add the low and the high and divide by 2. So take the lowest plus the highest and divide by 2. That's my mid-range. Measures of central tendency. How are these things grouped around each other? And then we also have measures of dispersion. And measures of dispersion measure how spread out things are. And there are three main measures of dispersion. First is the range. Now the range, don't get the range and the mid-range confused. The mid-range, add the highest and the lowest and divide by 2. It's the average. The range is just take the highest number, subtract the lowest number. So if we had test scores and the lowest score was an 80 and the highest score was 100, the mid-range, 80 plus 100 is 180, divided by 2 would be 90, but the range would be 20. The mid-range, remember, is a measure of central tendency, where the range is dispersion, how spread out the data is. The next one we should know and be familiar with is standard deviation. Again, how spread out the data is. We're going to spend a lot of time with standard deviation a little bit later. I'm going to kind of skip it early on, and we'll come back to that one. And then the next one is quartiles. And the different quartile array. Now the calculator is going to do a lot of this for us. We're going to be able to enter our data, and the calculator will give us the mean, the mode, the median, the mid-range, the range, standard deviation, and all the quartiles that we need in the quartile array. The lower quartile the 25% of the data. The upper quartile has 75% of the data. The middle quartile is the median number, and the zero quartile at the very beginning is the lowest, and the one at the end is the highest there. We're going to talk about quartiles here in a moment. But these are our main different measures that we're going to use to describe a data set. All right, once we've got these numbers, these measures, and what do they mean, how else can we describe our data set? Well, there's a couple of different ways. One of the methods is we can draw a histogram. Now, be careful. A histogram is not really just a bar chart. There's a big difference between a histogram and a bar chart. From a histogram, we're going to use another way of displaying data, something called a frequency table. And just as it implies, a frequency table gives us a list. I know I'm not doing a lot here with these definitions. We're going to do an example here in a moment. I'm just talking about these things. So a histogram kind of looks like a bar chart, but there's some big differences. One of the differences between a histogram and a bar chart is there's no gaps between the bars, because a histogram shows continuous data. The horizontal axis is on a continuous scale on a histogram, but on a bar chart it has categories. Like on a bar chart, I could have A, B, C, D, and how many A's, how many B's, how many C's, and how many D's. But on a histogram, it would be the numbers, 0 to 50, or 0 to 59, 60 to 69, 70 to 79. So a little bit different between categorical data and continuous data. A bar chart, the width is always the same and really isn't relevant to the exascale. But for a histogram, the width of each of the rectangles could span the width of the data that it represents. All right, so what I'd like to do is I'd like to take an example, look at an example of this, and I'm going to look at example number 3 out of the textbook. It's on page 320. So if you don't have your textbooks, that's okay. Don't worry about it. We're going to look at it. You'll be able to play the video again and kind of go back and talk about it. I just want to talk about some of the issues. So I've got a copy of that page here. I'm going to pull it up. We're going to take a closer look at it and talk about it. All right, here we go. Oh boy, it's really small, isn't it? Well, you can take a closer look at it a little bit later when we get home. Let me just talk about what's going on here. So in example 3, the weight of 50 different baby chickens that just hatched a week ago were recorded on the following table. So this is my table. That's just the raw data here. That's just raw data. So the first chick I measured was 22.4. The next was 20, 23.3, 25.2. So this is just the raw data of the weights of the baby chicks. So now we're going to take this raw data, it's not in any order, and we're going to create a frequency table. Now on the frequency table, we're going to have different intervals. Now I noticed that the smallest, the lightest chick weighed 19.5, and the heaviest one was 25.5. So I'm going to break it into these classes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different classes. The class width has to be the same. So 19.5 to 20. And then from 20 to 20.5. Now look at 20. If the chick weighed exactly 20, they would be in this class. It's very important that the classes, the class intervals, do not overlap. Any one piece of your data cannot be in more than one class at a time. So I don't know if you can see it here, but 19.5 is less than x, less than or equal to 20. 20 is less than x, less than or equal to 20.5. So a chick that's 20 would be in that first class. A chick that's 20.1 would be in the second, all the way up to 20.5, including 20.5. And then in third class, bigger than 20.5, all the way up to and including 21, and so on. So each of the class widths is 0.5, the weight of 0.5. And again, these class widths, they cannot overlap, and they have to be equal widths. And then we go and look at our data and say, well, how many chicks were in this interval, 19.5 to 20? Well, there's 3 of them. How about 20 to 20.5? Well, there was 5 of them. 20.5 to 21, including 21, only 1. Greater than 21, but less than or equal to 21.5, there were 6 chicks there. Greater than 21.5, less than or equal to 22, 2 chicks, and so on. You can see the frequency there. So this is a frequency table, and just like the name implies, I've got my different classes. Notice this is continuous data here. It doesn't just say, you know, A, B, C, D. It's not categorical data. It's continuous data. And how many times did that occur? So we know that the minimum chick was 19.7 actually. The biggest chick was 25.2. So if I subtract them, I get a range of 5.5. And then you can see how they did the categories here. Not really terribly important right here. And then I want to focus in on the histogram here. All right, I'm going to zoom in a little bit so I can talk about this. And it won't let me zoom in. I didn't know that. Oh dear. So it won't let me zoom in. So this, I apologize. Taking a look at this, at the bottom here, I've got all of the different class weights from my intervals. Here I've got the frequency, the number of chicks, 0, 1.5, 3, 4.5, 6. I really don't like the way they did the frequency. 1.5 doesn't make sense. Could you have 1.5 chicks that weigh that much? No. I think the data here should be 0, 1, 2, 3, 4, 5, and 6, because the biggest frequency was 6. Notice how all of the bars are connected. What if one of these classes was 0? What if there were no chicks that weighed that amount? Well, then the bar would be 0. It would just be a line down here at the bottom. So again, very small. I'm sorry about that. I thought I could zoom in. I can't zoom in. So take a look at this. It's on page 320 in your textbook. Difference between a bar chart and a histogram, a frequency table. And the histogram is created from the frequency table. All right, let's take a look at another example. I wanted to do another example that's in the textbook, and then we'll actually take a look at one that's done for us, and then in the next video we'll actually create one ourselves. The next example in the textbook, example number 4, the next page, 321, it says we want to examine the eggs that he's trying to hatch into chicks. They've had 25 trays of 24 eggs in each tray, which he placed in the incubator. The number of hatched chicks per tray is shown in the table below. So of the 24 eggs that were in the 25 different trays, how many actually hatched? In the first tray, 12 of them did, 18 here, 17 here, 13 in that tray, 9 in that tray, 21, only 2 in that tray, as much as 24 in that tray. It doesn't look like any tray, this had all 24 eggs. I think that was the only one that had all 24 eggs in there. Now, what kind of data is this? If I was going to do a sampling here, what does this really look like here? Strata, right? It's broken into different strata, and they're all they're all 24 eggs in each of these 25 trays, so I could do a good subsample if I wanted here. So we're going to take a closer look at this data, and we're going to break it into the number of eggs, and we notice that the smallest number of eggs was just 1 in that tray. The most is 24 in that tray. So we're going to break it into 1/2 of an egg to 3.5 eggs, which is kind of silly using the 1/2 and 3.5, because the only numbers that would be in this class would be where 1 egg hatched in the tray, 2 or 3. Here would be 4 and 5 and 6, 7 and 8 and 9, 10, 11 and 12. Notice how all of the classes have the same range of 3 eggs hatching. Here it is as a histogram. The number of chicks hatched from the 24 eggs and how many times. So how many times was there only 1 or 2 or 3? Notice I didn't include the number 0 in my class because there were no trays that had 0. So how many frequency table, how many times was there 1 or 2 or 3? Twice. How about 4 or 5 or 6 hatched? Twice. 7 or 8 or 9 hatched? Twice. 10, 11, or 12 hatched 4 times. 13, 14, or 15 hatched 8 times, and so on. You can see that. And the number here is the number here is actually discrete because it's not continuous. You couldn't have 3.27 eggs hatching. You're either going to have 3 or 4. So interesting here that the numbers are discrete, unlike the previous problem where the weights were continuous. I mean, the weights were continuous, because I could have everything here. They're discrete. All right, so I want to create a histogram of this data. So this part here is going to be on my x-axis on the bottom. These are going to be all my classes. And then the bars will be these numbers here. So it looks like on my x-axis I'm going to have to go from 0.5 all the way to 24.5. And probably might be easier just to do them in groups of 2 to 4, 6, 8, 10, 12, 14, 16, 18, 20, and so on. And then the frequency is going to have to go from, my smallest frequency is 1 all the way up to 8. Probably just do 0 to 8, or maybe go a little bit higher, 0 to 9 or 0 to 10. So it looks like my y-axis 0 to 10, my x-axis 0 to 25. And if we put that all together, what would it look like? And again, I already know that this is going to be a very small table. I'm not going to be able to make it any bigger, but here it is. This is what the table would look like, ladies and gentlemen. So take a look. Again, I apologize. This is in your textbook on page 322. Notice the classes down here. 1, 2, and 3, 4, 5, and 6, and the little notes, the mid class here, 2 and 4 and 6 and 8 and 10, the numbers down here. The frequency going from 0 to 9 chicks, and we can see that the modal class was 8 chicks. That the most frequently occurring tray had 8 chicks in it. Clearly the modal class. Looking into the future a little bit, notice I've got a kind of a curve, an interesting curve here, the normal curve. If I ignore all that data, I've got rectangular data here where it's the same number, the same frequency. All of these things are going to be important a little bit later. All right. Normally at this point I would have a discussion about the data, but since I can't interact with you, we'll put that off until later. All right, so now I'm going to hit the pause button here, and then when we come back, we're going to do a sample problem. I'm going to start with a data, and then we are going to create a frequency table, and we're going to create a histogram in the next lesson.